So LTER, or long-term ecological research, is just fundamentally important in environmental science. Coming on this trip today, here where we stand right now, illustrates why we need a long-term ecological research approach and a long-term ecological research network, a network of sites. We look around us here and we have many great mysteries in the environment. Why are these conifer trees here and yet just a few meters away there are broadleaf trees? Why do we have this dense understory of bamboo? How did this ecosystem come to be assembled the way it is, and how is it changing? Because the environment is changing all the time. And so we recognized about 50 years ago that in environmental science we must have a network of sites for long-term observations so we can understand how these ecosystems, these assemblage of organisms, how do they work and how are they changing over time. And if we have a network of sites, it allows scientists from different disciplines to come together and to come together for many generations. So to understand this place where we stand now, we have to know about soil and hydrology and microbiology and plants and even something about humans that use the area. And if we have this site here for 50 years or 100 years, then multiple generations of scientists can come and work together. And these are some of the hardest problems that we face in science. In science, we're trying to understand the human genome, and we're trying to understand the formation of the universe. We're trying to understand the assembly of these communities is one of those great challenges, and long-term ecological research is very important for that.
There are a lot of good reasons to focus on nitrogen, and the biggest reason is simply that nitrogen is essential for life as we know it on Earth.
Phosphorus are disproportionately important for water, nutrient, and trace gas fluxes locally. Our dominant tree at this elevation, the Dactyloides excelsa.
ILTER provides a great network for exactly providing the resources to build up such a harmonized data sets.
You can see in case of green tea, after 1 year you have a tea. So we will install tomorrow the tea bags in the experimental part that we have visited.
The ILTER Nitrogen Training Program is designed to expose young researchers to the state-of-the-art approaches of the nitrogen cycles in ecosystems with key ecosystem processes and implication for the environmental pollution.
Watershed. It's the most gentle watershed, and lower part is very gentle watershed. Higher nitrate, more flash the nitrate from soil. And opposite will be DOC. The area influenced by seasonal flooding of the river is covered with broad-leaved species. But the area not influenced directly by stream water is dominated.
Students from different nations, they have to collaborate together, discuss among students. So this is a really excellent opportunities for students to learn how to conduct long-term ecological study.
We have students and professors from different backgrounds. So instead of just looking at one part of the soil nitrogen cycle, we can look at so many different aspects of it. So it kind of interdisciplinary kind of approach. So we look at the whole cycle, not just one specific aspect.
I was interested to take this course because I wanted to learn new techniques to measure the nitrogen cycle from experts in the field and to see how to take those measurements in long-term data sets.
I'm from Brazil. I'm a PhD student in Brazil. I work with fragmented forests, so it's completely different from what I'm used to work.
During this course, I really enjoyed discussing with scientists from other countries, and I learned a lot from them.
And it's pretty interesting also, to get to communicate with other researchers from all around the world, and to get to know what kind of field studies and statistic analysis are made in other countries than your own. So that was mainly the biggest motivation for me coming here.